Okay, so today we are going to talk about the intro to geometry, the geometrical inequality. Okay, so the first problem is we have the 4 point. Okay, it's w, x, y, and z. Okay, so they mention we want to pick somewhere a point, and we want this point, all the distance to this center point at together is the shortest, right? So by this one you can try is the shortest is the crossing point. Okay, so if we pick any other point, for example, right, you can see according to the triangle, right, the two sides add together is greater than third sides, right? The two sides add together is greater than third side. So the shortest side is the segment, the intersection of the two segments. So for the second problem, okay, so we have the O pick the O run pick the number, for example, is the X, and Michael pick the number is Y, and Joshua pick the positive number is Z, which is smaller than the X. Okay, so no matter what the number Joshua pick, so this one can be any number, right? So Z is free to choose, and we always can create a triangle. Okay, so no matter what we pick Z, right? Z could be any positive number. So that means the X minus Y. Okay, let's assume that without loss of generality, right, we can see X greater than Y. Otherwise, Y greater than X is the same. So then we need the X minus the Y, right, should be less than the Z. Okay, because Z is free choose, right? The only thing for the Z we know it's belong to a positive number, right? Okay, so for any Z, it need to be possible. So the only way is the X minus Y is equal to 0 to make it possible. Okay. Next, to show that it is impossible for the 5-point star of this one, we have the AB greater than BC, CD greater than DE, DEF greater than GF, GH greater than HI, and IJ greater than AJA. Okay, so let's do it. Let's draw a big picture. Let's say it is possible. Okay, so it is the A, B, C, D, E, F, G, H, I, J. Okay, let's mark the angle is 1, 2, 2, 3, 3, 4, 4, 5, and 5, 1, right? So from the AB greater than BC, now we have the angle 2 is greater than angle 1, and the CD greater than DE, we have the angle 3 is greater than angle 2, then the EF greater than GF, so we have the angle 4 is greater than angle 3, then GH greater than IH, we have the angle 5 greater than angle 4, then from the JI greater than JA, we have the angle 1 greater than angle 5. Okay, so from this one, you can see 5 greater than 4, 4 greater than 3, 3 greater than 2, 2 greater than 1. So we have the 5 greater than 1. From this one is 5 less, 1 greater than 5, right? So that's why it is impossible. Okay, so we have the following constructions. We have 3 circles PQR and are drawn and such that no 2 circles have intersections. Then suppose we have a 4th circle that are all externally tangent to all of the 3, right? Let's assume this is the 4th circle. Okay, maybe I have to draw it here. 1, 2, 3. PQR, and we have a fourth circle. Let's see, this is the fourth circle of the A that is tangent to everything, right? So we can connect it, the two centers, okay? And the center will passing through the tangent point, okay? So we have the PQR, so this is TP and TQ and the TR. T means touch point, okay? Then we want to use the inequality to prove that the radius of the fourth circle. So this is the radius of the fourth circle is R. No, let's use the A. Okay, because I want to use the radius PQR to represent these three circles. Is greater than the radius of the Q, so we want to prove that A greater than the Q is the goal. Right, this is the A. So the way we can do it is we can see a triangle, the PAR. Okay, so in the triangle PAR, we have the two sides PA plus the R is greater than the PA plus the RA is greater than the PR. Okay, so let's see what is the PA, because it's touch point, right? So PA is equal to the A plus P, and the RA is equal to the A plus R. Then it's greater than the PR, right? PR is P plus 2Q, then plus the R, and also you need to plus the 2 distance, right? Let's see, this is the delta 1, this is the delta 2. Plus the delta 1 plus delta 2. These are all positive, so greater than the P plus R plus 2Q. Then we have the 2A plus the greater than the 2Q. Then we have the A greater than the Q. Okay, so this is the first way to prove it. And let's see what's the second one. So use the inequality relationship relating the order of the sides in a triangle to the order of the angle in a triangle. So this means in a triangle, okay, A, B, C, okay, and this is the B, this is the A, and this is the C. So if the A greater than the B, okay, means the angle opposite to oh, I'm sorry, this is the ABC, okay. If A greater than the B means the angle A, opposite side to the side A, okay, is greater than the angle B, okay. So the bigger angle has the longer opposite side. So now let's see how we can use this to prove, okay. So the key here is you can see in a triangle we can only have one, okay. For any triangle, okay, we can only have one. Have only one angle greater or equal than 90 degrees. Okay, if we have two, then two angles are together already greater than the 180. So that's why. So how we use this? So now we can take a look at the triangle. We can take a look at the triangle APR first, okay, and with the cutting line of the AQ. So you can see this AQ, when you're cutting it, we have two angles, right? We see one is alpha, one is 180 minus alpha, okay? So over these two angles, okay, either alpha greater or equal than 90, or the 180 minus alpha will greater or equal than 90, right? one of them must be true. Okay, so let's assume just alpha greater or equal than 90, because without loss of generality, right? Otherwise you can swap it. So if this is the alpha greater or equal than 90, right? So that means the a plus p, right, is greater than the pq. That means the a plus p is greater than the pq. The pq is the p plus q plus delta 1 is greater than the p plus q, right? So now you have this one, you can see a greater than q. Okay, next. So I have a convex quadrilateral, okay? Let's draw a quadrilateral WXYZ. WX greater than the WY. WX, Y, and Z. Okay, so something like this. Okay, so we have the WX greater than the WY, right? So means this angle will be greater than this angle. So let's say this angle is alpha, then this angle is alpha plus something. Okay, so the goal is we try to prove the XZ greater than the ZY. Okay, so we can see the ZY, right? This angle is alpha minus something. For example, minus P. Okay, yeah. So this angle is alpha plus delta plus Q, right? P and Q are all greater than 0. So that's why we can see the alpha plus delta plus Q is equal to angle ZYX is greater than the alpha minus P is equal to angle ZXY. So now we know the ZX will greater than the ZY. Okay. So we let A, B, C be 3 positive number. Okay, so the A, B, C are the real positive number. Okay, so we want, and such that we have the cyclic inequality here. So prove that A, B, C can be a length of the triangle. So without loss of generality, right, we can see A less or equal than B less or equal than C. Right, no matter what, we can make an order, right? So because these are all cyclic. Okay, so that means to us is the most important thing we want to prove is A plus B greater than C means they can create a triangle, right? Okay, so now let's see how we can use this. We know the A square plus B square greater than the C square, right? Okay, so then the A square plus the B square plus 2AB must greater than the A square plus B square plus greater than the C square. So this one helps us to know the A plus B greater than C. So that's why they can make a triangle. Prove sum of the length of the diagonal of a quadrilateral is okay, so we can draw any quadrilateral. Okay, let's see, it is A, B, C, D. So we can have the two diagonal. Yeah, we have the two diagonal. Okay, so we want to prove this is the A, B, C, D. We want to prove the two diagonal will be the add together is greater than the half of the A plus B plus C plus D, right? With the goal is to prove the AC plus the BD, okay, will be greater than half of the A plus B plus C plus D. Okay, so how we do this is there is a very popular way is to take the midpoint. why we take the midpoint? Because we're converting everything to a quadrilateral. Say MPQ. Okay, so if we take the midpoint, right? So basic MN D, this is the Q. So you can see the MN is will be parallel to AC, right? And the PQ will also be parallel to AC. So we have the MN parallel and equal to the PQ and parallel and equal to the half of the AC. Now you have the MQ is parallel and equal to the MP and is also equal parallel to half of the BD. Okay, so now you see the sum of the AB plus the AC plus the BD is the diagonal is equal to the perimeter of the parallelogram, right? This is the parallelogram of the MNPQ. Okay, so now let's see the second one, right? So if this is the midpoint, right? So let's see all this point. Let me use another color. So you can see all this point, the red points, okay? All the red points are also the midpoint of this, right? And also cutting this. They are all the midpoint, okay? So let's connecting the midpoint of, let's see, this is HIJK, right? So you can see the HK is the midpoint, right? So HK is parallel and equal to half of the D, right? So this is the D over 2. Then this is the A over 2. Then this is the B over 2. Then this is the C over 2, right? So now we can see the HQ, the HQ plus the KQ is greater than half of the D, right? So that's why if you see the triangle inequality, you have this one plus this one greater than the half of the D, and this one plus this one is greater than half of the C, and this one plus this one is greater than half of the B, and this one and plus this one is greater than half of the A, right? So that's why you can see the AC plus the BD equals the perimeter of the parallel MNPQ is greater than half of the A plus B plus C plus D. Next is the XYZ. We have an angle of X is equal to the 20. So we have the angle of X equal to the 20, and the XY equals XY equals XZ. So it's an isosceles triangle. We want to prove the XY. Okay, so XY, let's see, this is the 1. Okay, let's see, this is the 1, so this is the A. So we want to prove the 1 is greater than the 2A, but less than the 3A. Okay, so I will give you some for the 3A is very easy to prove. So if you can think of this one to make using the X as a center, and using the XY, the 1 as the radius, so we can construct it a circle. We can construct a circle, okay? So then we have this, and we have this. So we have the 20, 20, and the 20, right? Through 3 of them. So in this circle, we have the these three are the equal. So this is the x, y, z, right? So this is the A, this is the A, and this is the A. Let's see, this is the P and the Q. So now we can see this is the 20, 20, 20, and this is the 1 and the 1, right? So that's the XP and XPQ, right? XPQ is isosceles with the vertex angle of the 60, right? So that's why triangle XPQ is equilateral triangle, right? So we know the PQ is equal to XP is equal to XY is equal to 1. Okay, now the only thing we want to prove the PQ is equal to 1 is less than 3a, right? So this is obvious, right? Connecting the 2 points, you use the P, this is the 1 is the segment, line segment, okay? Line segment. And the other one, you need 3 segment. So of course, this one is true. So we solve, we prove one side. Now we need to prove the other side. So I use a little bit of the trick. Okay, so I drop the height because it's isosceles, right? So this is the 10 degrees. This is the 10 degrees. So we know the A is equal to the 2 times the sine of the 10 degrees. Okay. Then our goal is to prove the 2 is 4 times 2a is 4 times the sine of the 10 degrees is less than 1. So this is not very difficult to prove. Okay, let's see, we have alpha, okay, and this is the 1. So the sine alpha is the y. Sine alpha is the y over the 1, right? So you can see if we also draw a unit circle, right? So you can see the arc of this, right? This arc is called alpha in the radius, okay? This is called alpha in radius, okay? So this is the y. This is the y, okay? So you can see the alpha will be greater than the y, right? Okay, so the alpha in radius, so that's right, 10 degrees in radius, 10 degree over 360 times 2 pi, right? So we want to prove the 4 times this one is less than 1. We know 4 times this one is less than 4 times the 10 over 360 then times the 2 pi. Okay, then we want to prove this is less than 1, right? This is equivalently to prove the 2 pi over 9 is less than 1, right? So equivalently want to prove the 2 pi less than 9. Okay, this is of course because pi is less than 4, right? So so you can see the 2 pi will be less than 2 times 4 is 8 is less than 9. That's why. Okay, you can go back to see this. So the next is we have the ABC and AB equals A prime B prime. Okay. So we have the A, B, and C. Okay, then we have the C prime. So that's why we have the AC equals to, let's say this is the A, and this is the B, this is the B, and we have the BAC. Okay, this is C prime, this is the C. So we have the BAC is greater than the BA prime C prime, right? BA prime C prime and BAC. So let's assume this angle is is alpha, then we want to prove the BC is greater than the B prime C prime, right? So B prime C prime. This is also the B prime. This is also the A prime. Okay. So let's think about the angle is the. Let's think this angle is beta. Then we have this angle is also beta, right? So now we have this angle, okay? The angle, the B, C, and the C prime is less than angle beta, right? And we have the angle B, C prime C, that's this angle, right? Is greater than beta, right? So that's why we have the angle B, C prime C greater than beta equals beta greater than the angle B, C, C prime. So that means we have the B, C, C, B, B, C prime C, that's this angle, will be greater than this angle. Okay, so according to the big angle have a longer side, so that means the BC will be greater than the B prime C prime. Okay, so last is the proof that the distance between any I have a triangle ABC, ABC. So prove that any distance inside the 2 points inside the triangle is not greater than the half of the perimeter of the ABC. So we want to prove any of the segment PQ inside the triangle will be less than the half of the A plus B plus C. So we have the A, B, C. Okay, we can reorder everything. Let's say A greater less than B less than C. So the longest side is C, right? So if you can put any points inside the PQ, right? Your PQ will be less than or equal than C. The longest you can achieve is the C, right? We want to prove, so this one will be less than half of the A plus B plus C, right? So this is the equivalently, we need to prove the half of the C is less than half of the A plus B, right? So equivalently, you know the A plus B greater than C is a triangle. That's why you can prove it. So that's it for the problem of this chapter. Thank you.